Hello, thank you for joining us at the Charged Virtual Conference on EV engineering. The topic of this session is how to accelerate EV time to market through robust subcomponent testing, brought to you by Donaldson Company. There will be a Q&A session after the presentation, so please submit your questions at any time by clicking the Q&A button on your screen. Now, please let me introduce our speaker, Matt Good from Donaldson. Welcome.
Thank you for the introduction. As mentioned, today we're going to be discussing how to accelerate EV time to market through robust subcomponent testing. For today's agenda, we're going to start off with a quick introduction of the Donaldson Company. Next, we'll step into the product design approach for subcomponents of electric vehicles. And in this subject, we're going to go into a case study of the battery ventilation technology that Donaldson has developed. In this case study, we're going to highlight how robust testing has reduced time to market for us and our customers. And lastly, we'll open it up to a question and answer section. Now, Donaldson was founded over 100 years ago by Frank Donaldson for air filtration needs of agricultural equipment. Since then, it's grown into a huge company that's solving customers' complex filtration needs. With industries ranging from process filtration to on and off-road transportation, industrial to defense, we are one of the largest providers of unique filtration technologies and high-quality filters and parts. Donaldson itself was founded in 1915 here in Minnesota, United States. And today it's grown to a $3.3 billion company with over 14,000 employees globally. These employees range in a set of locations from manufacturing plants located throughout the globe to distribution centers. This enables Donaldson to not only be a global company, but a local company for your filtration needs. In addition, we're in a diversified markets, as mentioned previously, and have a world-class R&D center to develop unique filtration solutions to any problem you might be facing. So, with a little bit of background on who Donaldson is, let's talk about our product design approach. Here at Donaldson, our product design approach starts with the ideation phase. This starts with us talking to customers or customers approaching us with filtration problems that they need solved. This can range anything from filtration of medical devices to agricultural equipment, or as we've seen recently, the electric vehicle revolution. These ideas and customer needs are put together with the technologies we have at Donaldson to create core technologies or core capabilities. A core technology is going to be a product that's released in the marketplace to solve that filtration need, while a core capability is going to be a way to validate that product and ensure it's meeting the customer's expectations or problem. Some examples of this could be an engine air filter as the core technology, and the core capability, a way to test that filter that is ensuring that it's as close to the application's end goal as possible in the lab. Now, once we have the core technology and core capability planned, completed, we can then break into an off-the-shelf solution, which is the same product we developed for other customers, or we can do a derivative solution, which is taking that existing product and changing the shape, size, or color to meet different needs. Now, each one of these steps take a uniquely different amount of time, and we're going to step into that here with our time to market approach for each of these parts. For our core technologies and core capabilities, this can range from 2 to 5 years, depending on what kind of development process is being conducted. It all starts with project planning to make sure we have clear expectations and understand how the product should function in the field, understand the customer needs, and understand what kind of testing is going to be required to make sure the part's validated. Next, we go into the concept creation phase, which is the blank napkin sketches to initial CAD drawings and prototypes. Once we've proven that the filtration concept works, we start stepping into the design refinement stage. This is working with manufacturing centers throughout the globe, or working with our internal R&D facility to make sure that we can make the products at the scales we need. Once we've made a couple small production runs and validated the part through our validation testing, we'll step into production capability, increase in scale at our manufacturing plants, and lastly, launch the product into the market. Now, this can take a large amount of time, and one thing we offer is that derivative solution. So is there a core technology at Donaldson that we can adapt to use for your needs? A derivative is going to take less time than a core technology because we don't have to start from the blank napkin. We have a finished product that's been validated and we know works, and we just have to change a few aspects of that filter or vent or whatever that product may be to fit the need. Because we're only making small tweaks, the entire time for this will be much less, sometimes half or 4 times less than a core technology or core capability. Additionally, you're able to de-risk because you know the performance of the part when you start the project. Now, lastly, an off-the-shelf solution, so a core technology that's already been released, is going to be the shortest time to market. All you need to do is some quick planning and scheduling with Donaldson, and then you can have high quantity parts over in your hands. So now that we know a little bit about the product design approach and the time that each one takes, let's talk about the case study for battery ventilation. The idea of a dual stage burst vent came from a combination of both Donaldson and customers that came to us with a problem. First off, we wanted to increase the value of our vents for electric and automotive applications by adding dual functionality. A traditional vent is used as a pressure equalization device to ensure that the pressure inside a hermetically sealed box is constant and doesn't exceed the failure points of the seals. Additionally, because it is sealed, it keeps water, dirt, and contamination out of that enclosure. Now, with the advent of lithium-ion and electrification, we've noticed a growing need in the industry for an emergency degassing component. This is a vent that will open up and enable a large amount of hot gas out of the enclosure to ensure that it stays below rupture point. Now, utilizing the Donaldson technologies of Tetra Tech's ePTFE media, injection molding experience, and manufacturing excellence, Donaldson was able to partner with multiple customers to understand what the market needs are, how our product should be sized, and what kind of performance specs we would need to compete in a dual function vent for automotive applications. With the planning phase complete, we then stepped into the prototype phase. This is the napkin sketch and starting to really tackle the problem. We started off by creating the 3D printed prototypes and testing them in our laboratory with some new testing methods we had to develop. As seen in the video playing on the right, this is our dual stage burst product going through a burst test. As I play it again, you can note that the Tetra Tech's ePTFE media is expanding, and once it hits a certain pressure, ruptures open, enabling high airflow out of the battery pack. With the product tested on small sample sizes and proven as working, we were then able to now step into the design refinement stage. Now, design refinement is where you spend most of your time. And just as Thomas Edison found out, it can take thousands of experiments before you finally get the final product that you're ready to go to market with. A lot of his light bulbs only lasted a few minutes, which weren't good for the market. Likewise, as we step our events into the design refinement stage, we wanted to make sure that it will survive any condition that it'll be faced that was identified with our customers. For this, we deep dived into the application requirements and identified some interesting edge cases, such as washing off the salt after a bad winter from the underbody is high temperature and high pressure water spray. So IP6K, 9K became a requirement. Additionally, we found out that dust loading from driving on rural roads could impact the vent life. So we included this. And vibration of any sort of off-road condition can impact vent life. So we wanted to make sure this was encompassed. With the deep dive into application requirements complete, we then started stepping into our design failure mode and effects analysis. This is where we take a look at the design, if manufactured perfectly, and identify where it may fail. Once we have identified those failure modes, we then put a risk score to it and try to look at either improving the design or validating and confirming what the actual risk to the component is. Now, one important thing to keep in mind, though, is every part that rolls off the assembly line is not going to be exactly the same. There will be some variation. So once we had our DFMEA complete, we started talking to our manufacturing plants to work on our DFM, or design for manufacturability. With this DFM came a process failure mode and effects analysis to understand how each part's going to vary as it rolls off the line. This introduced yet more failure modes and more items to test during our validation testing. Once complete, we were able to soft tool the product and start the Donaldson validation testing, which we'll touch on in the next slide. Once Donaldson was able to complete all validation testing and prove the part functioned, we then sent it off to our customers for systems level testing and ensure the event was functioning properly. Here at Donaldson, during any stage of a product development, whether it's a core technology or a derivative, we have a three-phase approach to the validation testing that we do. The first phase is our baseline testing. This is the testing to ensure that the vent is functioning as intended. Once the vent has proven its functionality and proven that it works, we then step into our durability testing. This is going to be those edge cases or whatever the part's going to be subjected to while it's in the field. This can include the high pressure water spray as discussed, dust loading, salt loading, chemical exposure, etc. Now, once the vent has been subjected to all these extreme cases, we then want to conduct a post-durability test. This way we can quantify the effect of whatever it was subjected to and ensure the vent is still functioning as designed. For our dual stage burst battery vent, what our testing looked like is something as follows. We wanted to conduct baseline testing to make sure the vent breathed and prevent water and dust from entering the cavity. Once it passed these two baseline tests, the part would then be subjected to the following durability tests, either concurrently or in series with each other. Once the durability test was completed, it then went to post-durability testing, which was making sure the vent still breathed, still kept water and dust out of the enclosure, and then bursted, so opened up during that pressurized event, and opened up enough to enable high degassing airflow. Now, because the electrification industry is pretty new still, a lot of industry standards have not been developed on how to test and validate parts for these applications. Because of this, one of the parts that took a long time during the development was making custom testing procedures to ensure that our vent would pass the expected life that it would see in the field. Highlighted in green are industry standard ISO, NIST, or other tests that are common for automotive applications. Highlighted in blue are Donaldson custom tests that we developed in-house, which we deem as impact vent life and impact vent performance. These were identified both between us and those customers that we were working with through the development of this project. Now, just to walk through one of these custom tests is our burst test, as seen in the top. You might notice that there are three burst tests: a burst, high temp burst, and low temp burst. This is to ensure that our product is always going to work, whether it's in the low temperature of the Siberia in Russia or it's high temperature in Abu Dhabi. We wanted to test the temperature extremes of the product and where it might go and make sure that the part would function in those environments. Now, with every development process, you always run into last-minute hiccups that cause timeline delays. And just one of those many lessons that we learned was the introduction of foreign object debris on the sealing surface of the vent. Now, during our validation testing, we noticed that water ingressed through the vent during IPX7 testing at the beginning of test. Now, upon disassembly, we noticed that there was foreign object debris, or FOD, identified on the sealing surface. Because we have some manufacturing excellence and quality reports of the parts as the parts leave our manufacturing plant, we were able to identify that the parts were FOD-free as they left the plant, and this FOD had to have been introduced somewhere between leaving the plant and installing onto the test fixtures. Because it was difficult to identify where exactly this was introduced, we took the route of quantifying what's the maximum size of debris that could be on the seal, which would create water leakage into the enclosure. By determining what that size is, we were then able to implement a quality inspection to make sure that that size was being captured, and we can recommend cleanliness specs to our customers to ensure that the assembly line where these are being installed has the proper cleanliness to prevent this kind of failure occurring. Now, some takeaways from this root cause was almost 1 month of root cause activities of foreign contamination size testing and a half month for that corrective action implementation. Now, while this doesn't sound like a lot of time, this is just a short finding, and it did cause a 1.5 month delay, which could be the difference between launching a product on time and not meeting your deadline. Now, Once Donaldson was able to develop that core dual stage burst technology, we then were able to quickly branch off and do derivative products. As seen on the right, we have multiple dual stage burst products designed for different applications. The top two photos are seeing our quarter turn bayonet design used to install into sheet metal enclosures. Varying leg heights are available for varying enclosure thicknesses. Next is our M32 threaded version to go into castings or nuts located on the battery pack enclosure. Lastly is a bolt-on version for high variation in surface flatness conditions, such as stampings or injection molded plastic. Now, the goal and really the key to these derivative projects was keeping that core technology the same. You can see kind of visually on the pictures on the right, the top of all these products look identical. That way, when we actually do our validation testing, we only have to ensure that the new seal designs are meeting up to those validation requirements. And what this looks like from a timeline perspective, on the left here is our core technology validation test. This is identifying the Donaldson custom tests and the industry standard tests. Now, a derivative is going to have much less testing around it. Now, taking a look at the products that we're talking about, on the left, the core technology, our quarter turn bayonet, we had to make sure not only was the quarter turn bayonet sealing properly, but we had to make sure that the bursting membrane was working properly and having the degassing airflow and the normal breathing as we intended for the product. Once all this was proven and we did the derivative, the only thing we needed to validate was the new interface to the battery pack enclosure. Because we're able to reduce the number of tests that we conduct, we're then able to shorten the timeline from 2 to 3 months of testing down to 1. As we take a look at the Donaldson product design approach, going from ideation to core technologies and core capabilities, this is where Donaldson and most companies globally spend a lot of their R&D time. They can spend 2 to 5, even longer years developing this core technology or core test capability to make sure that we're solving the problems of the customer. Next, once we have that core technology and core capability developed, we can then either quickly offer an off-the-shelf solution today, or in 6 months to a year, we can make a derivative solution that's a different size for the application or different color. Now, some key takeaways that we just wanted to make sure everyone walked away from here is if you have a validated subcomponent, you can accelerate your time to market by 2 to 4x. You don't have to do as much of the validation testing, and you're able to have a proven part that has been subjected to robust validation and passed. There's very little risk of unforeseen circumstance coming up during that validation. Next, we wanted to make sure that people understood that the electric vehicle market is quite new, and there are not standard test methods out there for every edge case or condition that you might see. So when you're taking a look at the subcomponents, make sure that those test methods are conducted and are meeting all the anticipated events that the vehicle might see. Once you're able to do that, you can reduce your system level risk priority numbers through known piece part performance through all those edge cases. Lastly, who doesn't love prototyping fast? By using an off-the-shelf sample, you can begin prototyping as quickly as tomorrow when the parts show up, enabling a higher confidence in the end product performance. At this point, I'd like to thank you for your time and open it up to any questions the audience may have.
Thank you for the presentation. We'll now begin the Q&A session, so please submit any questions by clicking the Q&A button on your screen. I see we have a few submitted already. If you could begin by reading the question aloud, that would be great.
Hey, Matt. So we've got a few questions here for you. Our first question, do you offer testing services or manufacturing of products?
Hey, Matt, thanks for the question. So traditionally, Donaldson has been a company that will develop the core technology and do the manufacturing itself. However, if there are battery events that you'd like to run a comparison test to versus the Donaldson branded, we'll gladly offer those kind of competitive or product by product testing through our labs, through these Donaldson vent tests that we've developed.
Great. Another question here. Did you capture pressure temperature data from an actual thermal runaway event to create the burst testing protocol?
Matt, that's a really good question. So when we were going through the core technology and core capability testing, we were working with our end customers who conducted full-scale thermal runaway tests. And then we would work together with them to understand what data was useful from that test, and then fed that back into the Donaldson test that we developed. So we were able to understand pressure profiles and temperature profiles and figure out a way that we could simulate that in the lab so we could be as close as possible without doing a full-scale thermal runaway.
Great, thank you. Another question for you. When is the right time to start a core technology if the associated time to market is years?
That's a really great question. I think we can all agree that the only thing we cannot buy more of is time. With any of these core technology projects, the best time to get a company like Donaldson involved is really at its earliest stage. We often find that if we're able to understand the fundamental problem at its core, we can come up with maybe multiple solutions that we can then all vet out through that testing process and find the best solution for that answer. So if there is kind of a stage gate process that customers are using to develop new technology, if we can be in the prototype phase or that concept iteration phase, we're able to put a lot of valuable input into not only maybe what the product size is, but also surface finish considerations for the mounting interface and also packaging considerations. So parts around it can make sure they fit in on that assembly line. So earlier is always better, but if that's not an option, that's where derivative or off-the-shelf solutions are going to be a great choice, because you're able to actually take that end product, which can be provided as a 3D model. You could put it into your assembly and understand how it's going to fit today and start purchasing tomorrow.
Awesome. What are Donaldson's strengths that aid in their ability to produce products in this industry?
That's a really good question, man. So I think one thing that does set Donaldson apart is the test capabilities that we have here, not only at our Bloomington campus here in the United States, but also globally. We have engineering offices in Leuven, Belgium, and also our test capabilities at our manufacturing facilities, which enable us to create prototype parts, send them through a rigorous test campaign, whether it's thermal cycling, vibration profiles, or the custom test stands that we produced for simulating battery vents field experience. And then once we kind of test that technology and prove it, we can quickly launch the product out for our customers through our manufacturing facilities located across the globe. So the final customer not only gets a robustly tested part, but the manufacturing can be co-located near them. So you don't have to worry about long supply chains, as we found out through the last 2 years.
Great. We have another question here. Can you clarify the sealing surface affected by FOD in the case study? Is this between the vent and the battery enclosure?
Yes. So the case study that we talked about, when we saw the foreign object debris, we saw a small piece of contamination enter between the sealing surface of the vent and the battery pack enclosure. So this, while we don't know where the foreign object debris was introduced, whether it was from, just on the surface or where, we were able to find out what the maximum size is, and from there offer cleanliness specifications. Because we were able to go back to our quality records and show the parts left our factory FOD-free, we were then able to introduce those specifications and cleanliness requirements for the end customer.
Great. How can a company reduce the development cycle time?
That's a good question. So one thing that we've tried here at Donaldson is reduce the amount of change between components. And I think we're starting to see this a lot in the industry as we move towards platform projects. If you take a look at Donaldson battery venting technology, we've historically always used our Tetra Tech's EPTFE media as the core filtration fundamental. This media has been used within the industry for over a decade now, venting enclosures. And instead of starting with a whole new material and starting from scratch, we're able to take this existing core technology and just modify it slightly for the bursting characteristics that we were looking for. Likewise, as we take a look at electric vehicles rolling out, we're starting to see commonization of battery pack architecture, motor configurations, and other items like that. And it always helps to grab something that's off the shelf and been developed than to start with a blank sheet.
Awesome. Another question for you. How do you determine when a new product needs to be made versus creating a derivative product?
It's an interesting question. So one thing that we'll really try to do is if someone comes to us with a problem and they're asking for a new product, or we deem it as a new product, we really try to understand what's the problem we're solving. And it could be through fun problem solving methods such as 5 whys, but we really try to drill down to what are we trying to solve, and will our current technology solve that problem for you? As we kind of talked about, if you're able to take an off-the-shelf solution and try testing today, that's going to tell you a lot more than kicking off a core technology and spending a little bit of time developing it. However, if during that the 5 why process and finding the true problems or the problem we're trying to solve, if we're able to determine what that is and that we need a new technology, that's when we'll kick off that core technology and core capability process.
Great. And how would you set up the requirements of a new product to ensure success in the marketplace?
Sure. So when someone would approach a company such as Donaldson, we've actually started to create a form which will cover a lot of the considerations that are needed for either battery pack venting, powertrain venting, or other applications. Because we've been now working in this industry for a few years, we've kind of been able to understand what are common requirements that customers have. So if you're completely new to the industry or new to electrification, by working with a company such as Donaldson, who's been working in the industry for a little bit, we're able to help you kind of understand what those requirements can look like for a venting unit. Additionally, once you start actually producing your vehicle and running simulations on it, you can start understanding, what are those edge cases going to be? As we talked about in the presentation, in the northern states where you have salt covering the under chassis, bringing that through a car wash and seeing high temperature, high pressure water spray on the under chassis could cause some sealing concerns. So, trying to think through all those use cases is very important to not only creating a proper DFMEA where you have your risk scores, but understanding what kind of validation testing is going to be needed. So as kind of a summary, I'd say partnering with the company with some experience in the industry, while also working through what the vehicle is going to experience in the field.
Great. Thank you, Matt. And it looks like this is our last question for now. And that is, why has Donaldson created so many of these custom tests that you talked about?
It's a great question, Matt. So I think really at its core, as we took a look at venting technology and what specifications surround it in the industry, we started seeing some holes for how the product would actually function in the field. For instance, there is no standard test for how to make sure the vent will open properly. So that's, we really wanted to say, how can we test the product in our lab, and as it rolls out the door, have confidence that the part's going to perform in the field. And that's led us to, figure out a lot of different ways of testing our components. And we're starting to see regulation and the standards follow as this industry becomes more and more mature. So while today they are Donaldson custom tests, I foresee in the future these to become standard tests used by companies globally.
Great. Thank you so much, Matt, for your presentation. And thank you, everyone, for joining us. This session, along with all others, will be available on demand on the conference webpage, along with the PDF of the deck. So make sure you check out the Charge website for this session and any others. So thank you so much again, and we'll see you at the next one.
Thank you so much.